Okay, so in this question, they ask us which graph represents a linear function, and in the most, I guess, straightforward manner I can say it, if you see a linear function or something describing something that's linear, what are you talking about? Well, you're talking about something where the picture is actually a straight line. It's a literal kind of definition where your graph equals a straight line. Right? Because if you look at the word, it just says right in it, right? It says linear or line function, and that's what we're looking for. Now, by straight line, we mean one continuous straight line, so choice 3 is out. And in fact, choice 3 is the absolute value function, and you might be able to tell that because here, if you see what the graph is doing, remember, always think in terms of input and output with a function, or x and then y, right? X being the input and y being the output. So every point has an input and an output. And here on the absolute value function, let's say this is, I don't know, 1 right here. Well, if I go up, it would then be this point right here, or that y value, which is also 1. So this has the point 1, 1, but it also has the point negative 1, 1, right? Because the absolute value of negative 1 is also 1. That's a negative 1, positive 1. Let me clear it off, you might not be able to see that. Negative 1 and positive 1. So the absolute value function is made from these two straight lines where the y value is always positive for any x input. That's the definition of absolute value. And 2 and 4 are out because, well, these are curves. They're not lines, so they couldn't be couldn't be linear functions. They are functions. They're quadratic functions, and well, I think they're quadratic where the exponent is 2. But you can call both of these shapes parabolas. And these parabolas here, they're like U shapes. And in this parabola, notice the opening is not as wide as this one. Key distinction in the parabola is usually, let's say that it is a quadratic equation where it's some number times x squared. Well, right, the wider the opening, the lower the number here. Essentially, because the higher the number this is, the steeper the graph. Thus, the narrower the opening would be. Right here, this wide opening, you can imagine if this was 2, well, let me actually pick a different one, sorry. Let's say this is 2 right here. If you went up, right, the graph would hit like right here, or be at about, let's say, 4, so 2, 4. But this graph, if I go to 2, well, by the time I reach the graph itself, it's way higher because the rate of increase is much steeper. It's a narrower opening in the beginning, and that's because it's increasing at a steeper rate. So in general, the quadratic of a form ax squared, or something times x squared, the higher the a value, the steeper the graph, thus the narrower the opening. Now all of this boils down to choice number 1, which is your straight line function right here. And the reason it's a straight line is because the slope m is proportional. It's increasing at a constant rate, and that's the slope. So anyway, line function, linear function, the answer is 1 here. Hope that helped.